So if we have a to the n, where n is 1, 2, 3, 4, 5 or something like that, this really means that we're taking a times itself n times. So a cubed means a times a times a. It's nice to have this shorthand so we don't have to write 3 a's out. Now 3 times a is a plus a plus a. Let's go backwards. If we have x times x times x times x times x times x, that can be written as x to the 6th. Let's say we're multiplying exponents with the same base. Let's take a cubed times a to the 5th. A cubed is really a times a times a. A to the 5th is a times a times a times a times a. So altogether we have 8 a's. But 8 a's is the same as a to the 8th. We had a 3 and a 5 and we ended up with 8. So we can make an educated guess that if we have a to the n times a to the m, that we are going to add the exponents. Let's divide exponents with the same base. A to the 5th is really a times a times a times a times a. And a cubed is a times itself 3 times. We can cancel and we're left with a squared. How can we get from a 5 and a 3 to a 2? We can subtract. So our general rule, our educated guess would be that we take m minus n. Let's just pick any positive natural number, say 3. We know that 3 minus 3 is 0. So we're going to take a cubed over a cubed. From our subtraction rule, when we divide exponents, this is what a to the 0 is. If we have a cubed over a cubed, we get 1. So a to the 0 equals 1. An exception is 0 to the 0. Let's take 1 to the 0, you get 1. 2 to the 0, you get 1. 3 to the 0, you get 1. So you might think that 0 to the 0 is 1. That was where we fixed the exponent as 0. Now let's fix the base as 0. 0 cubed is 0. 0 squared is 0. 0 to the first power is 0. So you might think 0 to the 0 is 0. Depending on which pattern we follow, we get two different numbers. This is undefined. Now negative powers, let's take two numbers and subtract them to get a negative number. So let's take a to the 3rd power divided by a to the 5th power. That's a to the 3 minus 5, which is a to the negative 2. A cubed over a to the 5th, get 1 over a squared. So a to the negative 2 is the same as 1 over a squared. A to the negative n is the same as 1 over a to the n. Something to the 4th power means you multiply it by itself 4 times. Now, a squared is really a times a. So we have a total of 8 of them. How do you get from 2 and 4 to an 8? You multiply. So this would be a to the n m. Let's take a product to the power. We're going to have a times b times ab times ab times ab 4 times. Now let's rearrange it so all the a's are together and all the b's are together. We can do that because multiplication follows the commutative property. We have 4 a's and 4 b's. So we distributed that 4 through. So our general rule, we can guess that it's going to be a to the n, b to the n. Let's take a quotient to a power. So a over b to the 4th, put our numerators and denominators together. Well, our numerator then is just a to the 4th, our denominator is b to the 4th. We distributed that 4. So we can make an educated guess that the general rule of a over b to the n is a to the n over b to the n. Now let's analyze 1 over a to the n. From this rule here, this is the same as 1 to the n over a to the n. 1 times itself n times is just 1. So this is the same as 1 over a to the n. We've seen that before. This is equal to a to the negative n. Now let's look at if we have a over b to the negative n. From what we know of negative powers, this is 1 over a over b to the n. And from our rule up here, this is 1 over a to the n over b to the n. Dividing is the same as multiplying by the reciprocal. Well, now let's do this rule backwards. Compare what we started with and what we ended with. Our power went from negative to positive. A over b went to b over a. Take the reciprocal and make the power positive.